Hi, geometry classes. This is a circle unit, lesson 7, and we're going to talk about intersecting chords, secants, and tangents again, but today we're going to talk about the lengths of the segments that are formed by those intersecting chords, secants, and tangents. So there's 3 rules that we're going to learn about. First one is maybe the easiest. That's when I have intersecting chords or secants inside the circle. All right, so I have a chord right here. This is a chord, and this is a chord. The chords are not equal to each other, but the parts of the chord multiplied equal the parts of the other chord multiplied. So A times B equals C times D. All right, so again, the parts of one chord multiplied equal the parts of the other chord multiplied. The chords themselves are not equal to each other, but the parts of them multiplied are equal. All right, so an example just with numbers, say that this was 8 and this is 3, and this is 6 and this is 4. So if I was to add them, the whole chord is 10 and 11, so you can see they're not equal. But if I was to multiply them, 6 times 4 equals 8 times 3. Okay? All right, second rule, and we're going to practice all of these. If I have intersecting secants outside the circle, all right, basically A times A plus B equals C times C plus D. All right, so the part sticking out of the circle times the whole segment equals the part sticking out of the circle times the whole segment. All right, so the whole segment gets multiplied by the part that's sticking out, and the whole segment C plus D gets multiplied by the part sticking out. I tell the kids to remember this. I call it wee. It's the whole thing times the external part equals the whole thing times that external part. All right, and type 3, if I have an intersecting secant and a tangent outside the circle. You can think of it as the same rule that we just talked about, but the tangent, which is my A, gets squared. It gets multiplied by itself. And on the other side, I have B times B plus C, just like I did before. So it's the part sticking out times that whole segment. Okay, equals that tangent squared. But if you think about the tangent is the whole thing, and A is the part sticking out. All right, so let's try each of these because there's a lot to remember. First one just applies with the first rule. Okay, so the segments of one chord multiplied equal the segments of the other chord multiplied. So 10 times x equals 14 times 15. So 10x equals 210, and then I'm just dividing by 10. Okay? Second one is same rule, but now it's just going to get a little bit more complicated. So it's the segments of one chord multiply, 4 times 5x minus 1 equals the segments of the other chord multiplied. So just don't forget to distribute that. 4 times 5x is 20x. 4 times negative 1 is negative 4. I add 4, and x equals 2. This problem, though, wants me to find BD. So in order to find BD, I'm going to have to substitute. So 5 times 2 minus 1 is 9. So now I know this is 9, and I'm trying to find BD, which is that whole thing. 4 plus 9 is 13. All right, now here come my rules with the secants outside the circle, or the secant and the tangent. So remember, it's the outside part times the whole part, and 8 plus 19 is 27, and it's the outside part times the whole part. 9 plus x is going to be x plus 9. All right, so it's the outside part, 9, times the whole part, x plus 9, equals the outside part, that external part sticking out, times the whole thing, which was 27. Not too bad, as long as you just follow the rule. Distribute that 9, and I get 9x plus 81. 8 times 27 is 216. Subtract 81, and I get 135. And then I just divide by 9. All right, let's practice that again. So it's the outside part times that whole thing. Now, if I was going to add 3x plus 4 plus 8, that gives me 3x plus 12. The outside part, which is 7, times this whole thing. 5x plus 2 plus 7 is 5x plus 9. All right, let me change colors here just so we can see what's going on a little better. So it's the outside part, 8 times 3x plus 12, and the outside part, 7 times 5x plus 9. Okay, so if I distribute that, I get 24x plus 96. And if I distribute this on the right, I get 35x plus 63. All right, and I'm just going to bring the smaller x over to the other side because I have to combine those. And that gives me 11x. And then I'm just going to subtract 63. I'm just solving for x. Hard part's over. I'm just solving an equation right now. X equals 3. Right? And here I got, this is a tangent. So the tangent squared equals the part that's sticking out times that whole part. So 18 times x plus 18. 24 squared is 576, and that's 18x plus 324. I subtract 324, and I get 252, and then I'm just dividing by 18. Okay, try one that has an equation in it. Let me see. Yep, that was it. All right, so last one right here. So this is the chord rule. So the segments of one chord multiplied equal the segments of the other chord multiplied. So 12 times 10 equals x minus 1 times x plus 6. All right, so this one's going to be a little tough to do. 12 times 10 is 120. I have to use FOIL, so x times x is x squared. X times 6 is 6x. Negative 1 times x is negative 1x. And negative 1 times 6 is negative 6. All right, so 120 equals x squared plus 5x minus 6. I got to bring that 120 over to the other side. This is a quadratic, so it's going to have to be factored. So I need everything on one side. There we go. Now remember, if you need to find the factors of 126, that's not an easy one to do. Go to your calculator where you can enter an equation y1. I'm going to do 126 divided by x so I can see what the factors are, and then I'm going to go look at the table to see what the factors are. Just scroll down till you see some factors that will also that will combine together to 5. So the numbers multiply to 126 and they combine together to 5. Okay. And those numbers are 14 and 9. So it's going to be a positive 14 and a negative 9. They multiply to 126 and they also combine together to give me a positive 5x. And then each factor just gets set equal to 0 and solved. Now I get two answers. I'm not going to keep the negative answer because the length of a line cannot be a negative number. Okay, so x equals 9. And just so you know, I've included a summary of all the rules that we've learned for everything so far. So for central angles, inscribed angles, quadrilaterals, intersecting chords, all right? This is the first half of the circle chapter. We are continuing with circles, but we will just going to practice this again tomorrow.